Okay, this is extension 1 topic. It's exercise 7.10 in your textbook, and it's the division of an interval in a given ratio. Now, the formula is here. So the coordinates of a point P, now I've drawn it in this diagram down here. So this point P that divides the interval between these 2 points, x1, y1 and x2, y2. So the coordinates of a point P that divides the interval between the points x1, y1 and x2, y2 in the ratio of m to n. So the ratio here is m and this is n. So the ratio of m to n. So for example, m might be 2, n might be 1. So P, for example, is not the midpoint of AB. It might be, for example, 2/3 of the way up, for example, between A and B. So the ratio might be 2 to 1, or it could be 3 to 2, or anything else like that. So in extension 1, we learn how to divide an interval, not in the ratio of 1 to 1, but in the ratio, in any other ratio, okay? I mean, you could use the formula and do it 1 to 1, but we don't do that. We would then do the midpoint formula if we wanted that. Now, this is the formula that to get the coordinates of point P, to get the x value of point P, we do m times x2 plus n times x1 over m plus n. And to get the coordinates of y, we do m times y2 plus n times y1 over m plus n. Now, I don't actually learn that formula. I'm going to show you a quicker trick to use to do this, because I find that the formula is a little bit difficult to remember. So that is the formula, and I'm going to prove this formula anyway. So what we do, I'm going to draw the diagram there. Okay, and we've got the diagram there. I'll just focus it 1 minute. Okay, now for the proof. The point P, which has coordinates x, y, is the point dividing the interval AB in the ratio of m to n. Okay, if we know that, then we can say that the ratio of AP over PB, so the ratio of AP to PB is m over n. Now, if we draw ADC parallel to the x-axis, then and draw up some right-angled triangles, I'm just going to do that. So I've just drawn ADC parallel to the x-axis. I'm just going to write down the x values. Now, if this point A is x1, y1, then this position on the x-axis is x1. This position of D here on the x-axis, D is directly below P, and P has coordinates x, y, so the x-coordinate here would be x, and C is directly below B. I'm just going to put some right angles here, okay? So C is directly below B, and B has coordinates x2, y2, so the x value here is x2. So once we've drawn that up, and I've just drawn up made two similar triangles here actually, then we can see that the length of AD is x minus x1, and the length of DC will be x2 minus x. Now, we also know here, because ADC is parallel to the x-axis, and I've drawn two perpendicular lines up here, then we know that PD is parallel to BC, because this is a horizontal line and these are vertical lines drawn up, so we've got right angles here. Now, we therefore have parallel lines there, so I'm going to put in some parallel symbols. We can say that these are similar triangles, that ADP is similar to triangle ACB, but because we know about intercepts on parallel lines, we know that the ratio of AP over PB, so AP over PB is equal to AD over DC. And that's because of intercepts on parallel lines have the same ratio. Okay? Okay, now we know that AP over PB equals AD over DC. Now we're going to substitute in whatever values we've got there. Now we know that AP is m and PB is n, and it equals AD, which is x minus x1, and DC we said was x2 minus x1. And now rearranging this by cross multiplying. Remember, you can only cross multiply if you've got fraction equals fraction, which we do. So we've got m times x2 minus x1 is equal to n times x minus x1. And expanding this, we get mx2 minus mx1 is equal to nx minus nx1. Just running off the page there, so I'll just move this up a bit. Sorry about that. Okay. And now we're going to rearrange that again to have just the x's. I'm just going to put the x's on one side. Actually, sorry, there's a little error here. DC is actually x2 minus x. I'll just fix that up. So this is just an x, and this is just an x. So just fix those up. Okay. So this DC is x2 minus x. So this is x2 minus x. When I cross multiply, this is x2 minus x. And when I expand, I have an x here. So I'm going to take anything with x on the left-hand side. So I've got nx plus mx. And anything with x2 and x1 are going to go on the left-hand side. So I've got mx2 plus nx1. Now I'm going to factorize out the x. So on the right-hand side, x bracket n plus m. And on the right hand side I've still got mx2 plus nx1, and so therefore making x the subject, I will divide by n plus m. I get mx2 plus nx1 over n plus m, or I can just write over m plus n. Now that gives me the formula for the x value of the coordinate of the point that divides the interval in that ratio of m to n. So I'll just bring that other one, I'll show you that in a minute. Now similarly, you know how we drew this line ADC parallel to the x-axis. If we go back to the original diagram and draw, instead of drawing ADC parallel to the x-axis, if we actually draw it parallel to the y-axis and do a similar process along here with the triangle up there, using y values, we will actually come up with this other formula here for the y value of the coordinates p. Okay, so I'm not going to do that. Sorry, it's all a bit crooked. I'm not going to do that. You're just going to have to take my word for it there. Okay, so that's the end of the proof. And so I've just written that here. Similarly, we can prove that y equals my2 plus ny1 over m plus n by drawing an interval parallel to the y-axis. Now I won't do that because we're not even actually going to use the formula, but some people do like the formula. I really don't. So I'm going to show you another way of doing it, which does use the formula, but you don't actually know that you're using it. Now there are two types of division of an interval. So we're looking at internal division of interval AB and also external division of an interval AB. So here is interval AB from there to there. Now if P divides the interval AB internally, then P must lie between A and B. And if it is in the ratio of m to n, so I'm going to go ratio is m to n. Notice they're going in the same direction. So the ratio of AP to PB is m to n. So if P is dividing AB internally, then it lies between A and B, and the ratio of m to n is positive. Okay? Now, that is different to external division. So down here I've got external division of an interval. Okay, now here is my interval AB, and P divides that interval AB, but externally in the ratio of m to n. So I'm going to go from m to n here. Sorry, I'm looking at the ratio of AP to PB. So I go from A to P and I go forwards for that. So that's m. But then I come backwards for n. So the ratio of m to n will be negative. Okay? And this ratio here of m to n is positive up there. Okay? So if P is on, say, the right-hand side of B, AP to PB will be negative because m's going forward, n's going back. I've got interval AB here. If P is on the left-hand side of A, then the ratio of AP to PB, I go from A to P, and that's M, and then I go from P to B, that's N. Now again, we're going in opposite directions, so the ratio of M to N here will also be negative. And this is because M and N are measured in opposite directions, so they'll have opposite signs. So when we're doing when we're dividing an interval externally in the ratio of M to N, then the ratio will be negative, okay? And I'll show you how to do that when we do some examples now. And notice that if it's external division, then your point P will lie outside your interval. So P is on the right here, it's outside of the interval AB, and here P is on the left of interval AB, and it's also outside. Okay, this is the first example. It's from exercise 7.10, question 1b. And the question is to divide the interval 3, -2 and 2, 5 internally in the ratio of 4 to 1. Now it's very, very important that you do not go and swap the order of these points, or that you swap the order of this ratio. So you have to write the points as they are. So we've got the first point is 3, -2, and the second point is 2, 5. And it's being divided internally in the ratio of 4 to 1. Now that means that the ratio is positive. Now I want to set it up like that. So I'm just going to write up here that this is the point x1, y1, and this is the point x2, y2, and this would be the ratio of M to N. So I've just done them in pink, okay? Now what I'm going to do, I'm going to do this cross thing. So from the 4 I'm going across there, and from the 1 I'm going across here. Now this, instead of using the formula, we can actually just use this cross method. Now I'm going to actually just write what the formula is over here. Now to get the x value of the point that divides this interval in the ratio of 4 to 1, the formula is x equals mx2 plus nx1 over m plus n, and the y value of the point is my2 plus ny1 over m plus n. Now if we look at that formula and actually see what it is, to get the x value we're doing m, so it's this 4 times x2, so it's the 4 times the 2, then we go plus this n, so which is 1 times x1. So what we're really doing is we're multiplying this 4 by the x value here, plus we're multiplying this 1 by the x value over there, and then we've got our then we're dividing it by the addition of m plus n, so we're dividing it by 4 plus 1. So I'm just going to do that over here. So the x value is going to be 4 times 2 plus 1 times 3. So it's 4 times 2 plus, so it's 4 times 2. So the first value times the x over here plus the second value of the ratio times the x there. So it's 1 times 3 over, and then we add these two numbers here, over 4 plus 1. So you actually don't have to learn the formula if you set it out like this. That's the x value, and the y value is, again, this m. If we look at the formula, it's m times y2, so it's this 4 now times the y value. So it's 4 times 5 plus this second value, this n value, times this y1 value. So it's this one over here times the other y value, times, plus 1 times -2 over, again, you're adding the m and the n, over 4 plus 1. So once again, to get the x value, it's 4 times this x value plus 1 times that x value divided by 4 plus 1. And to get the y value, it's 4 times this y value plus 1 times that y value over 4 plus 1 again. And if we work that out, the x value is 8 plus 3, which is 11 over 5. And the y value is 20 plus -2, in other words 18 over 5. Sorry, I'll just fix that up. And the y value is 18 over 5. Now 11 over 5 is just 2 1/5, and 18 over 5 is just 3 3/5. So the point that divides the interval internally in the ratio of 4 to 1 is 2 1/5, 3 3/5. Okay, now I've just drawn this this question here in this diagram. Now it says to divide the interval 3, -2. Look, my diagram's not that much to scale, but it's not too bad. So 3, -2 and 2, 5 in the ratio of 4 to 1. So here is the interval from there to there, and it's being divided internally in the ratio of 4 to 1. We notice that, I'm going to call this P, the point that divides my interval. Notice that, so what will happen is that this part from there to there will be 4 times bigger than this section here, than from there to there. Okay, so I know it doesn't look quite 4 times bigger because it's not really drawn to scale that well, but notice we go from 3, -2 to 2, 5, and the ratio is 4 to 1. If you went and turned this ratio around 1 to 4, then the point P would be down here somewhere. That would be one part and the other bit would be 4 parts, which is why it's really important to write the points down in order. So you have to that has to be your first point x1, y1, and this has to be your second point x2, y2, and the ratio also has to be written in the exact order. Otherwise your answer will be incorrect, and we know our answer here, P, is 2 1/5, 3 3/5. And again, this is internal division of this interval, and so the point P lies between your 2 points that you were given. Now we're going to do another example on external division. Okay, here is example 2, which is from exercise 410, question 2G. And the question is to divide the interval -2, 2, 6, 7 externally in the ratio of 1 to 3. So we start by writing our 2 points. So we've got -2, 2, and we've got 6, 7 here. And we write the ratio 1 to 3. But because it's external division, you have to either do 1 to -3 or -1 to 3, because it's an external division, and your point will lie not between these 2 points, it will lie on one side of those points. So for external division, just one of the ratios has to be negative. Now I'm going to do this question twice for you. I'm going to show that if you do -1 to 3, you will actually get the same answer if we do 1 to -3. So what we're going to do, we're going to use that quick method of the crisscross. Okay, so I've got my cross in there. Look, I will write the formula out here, and the formula is as well x equal mx2 plus nx1 over m plus n, and that y equals my2 plus ny1 over m plus n. Look, I'm actually not going to use it, but I'm going to write it there. Now, if you don't use it that way, you can just automatically work out your x and y values all together. So I can work out my whole point x, y all in one go. So remember, we start from this left-hand side. So it'll be -1 times my first x value plus 3 times my second x value over -1 plus 3. Remember, you add those two ratios down the bottom. And then we start again and we do -1 times that y value over there. So this first bit here gets my x value of my point, and this second bit over here after my comma gives me my y value of my point. So again, -1 times 7 plus 3 times that y value, which is 3 times 2 over -1 plus 3, and we work that out. So that is equal to -6 plus -6, which is -12 over 2. Okay, and this is -7 plus 6, which is -1 over 2. So therefore, I can simplify that, and my point is -6, -1/2. Okay, now if I do a quick sketch of this. Okay, now I've drawn those positions here. Sorry, I just paused the video and had to restart, so there might be a little bit of a jump in the recording. So what I'm doing, I'm drawing the points here. So I've got the point -2, 2 and the point 6, 7, and I'm dividing it externally in the ratio of 1 to 3. Now remember, external division, my point P will not lie inside, but will lie outside those 2 points. So my answer for the external division of this point, I've actually labelled this as A and B. So this is point A and this is point B. My answer was -6, -1, 2, 3, 4, 5, about -6, -1/2, which is down here. So this is my point P that divides that interval AB externally in the ratio of 1 to 3. Now, I'll show you the 1 to 3 on this diagram. Remember, if this is point A and that's point B and it's divided externally in the ratio of 1 to 3, then we have to go from A, 1, that ratio there is 1, and then from P to B, this ratio here will be the 3 part. Okay, so actually I'll just make them a bit darker. So if we want the ratio of A to P is 1 and the ratio of P to B is 3, and notice that this first bit is 1 and this second bit is 3 times bigger than that first bit, and that's how that is an external division in the ratio of 1 to 3. Okay, now as I said earlier, it does not matter whether you put the -1 here and do a +3 there, or whether we do 1 here and -3 there. Now I'm just going to show that to you. So I'm going to do the question again. So I've got my points -2, 2 and 6, 7, and my ratio is going to be 1 to -3. Now I'm just going to move this page down. Okay, and I'm going to do this same process again. Got my little crisscross here, and let's start from the left. And remember, our point is going to be, so my point P is 1, so this first value times 6 plus -3 times -2, okay, over 1 plus -3, and the y value will be the 1 times the 7 plus -3 times the 2 over 1 plus -3. Okay, and that gives me the xy value point straight away. So I've got 6 plus, now -3 times -2 is +6. So it's 6 plus 6 is 12 over 1 plus -3 is -2. And my y value is 7 plus -6, which is 1 over, again, 1 plus -3 is -2. So if I just simplify that, 12 over -2 is therefore -6, and 1 over -2 is the same as -1/2. So this is my answer for my point P. It's -6/2, and up here for my point P, I also got -1/2. So it does not matter whether you do, sorry, something's just happened to my lighting there. It doesn't matter whether you do -1 to 3 or whether you do 1 to -3. You will get the same point for your answer. Okay, we'll go on to another example now. Actually, that's the end of this first video. I'm going to pause it now, and the other 4 examples will be on the second video.